Hello, everyone. Okay, thank you for the reply. So let's wait for a while. Okay, before we do the lecture today, let's try some example regarding the PN junction. So let's say if you have a silicon at T equals to 300 K, and then let's say your doping, your Na is maybe 2 times 10 to the power 14 cm minus cube, and D is 5 times 10 to the power of, let's say, 10 cm minus cube. US 11.7 mu. Then with the VR, let's say it's a 10V. Okay. The NI, you try to use the one listed in the table. Okay, try to calculate the VBI. Oh, not VBI, sorry. Yeah, okay, VBI should be there. Yep, you're right. SN, SP, W. Okay. And also, last but not least, magnitude E. Okay, based on all this information, try to calculate all these things. So once you have done, you type your answer in the chat box, every one of you. This is a silicon, don't forget. Okay. Anyone get any answer for this example? Han Xiang, have you done it? Okay. So how many of you have completed all the question? Anyone? So once you have done everything, type your answer into the chat box. Okay, what's your answer? 很香。Okay, we got a VBI 0.2772. The rest of you, do you get the same answer? Wong Chung Yi, what do you get? What about Teo Leong Ho, Wong Chung Yi, Brenda, what do you get for the VBI? Okay. Mana Wong Chung Yi? Mana Brenda? Okay. What about your SN? Go cancel your SN. Okay. 8.467 multiplied by 10 to the power of -8. CM or M? This one is in. Go cancel. CM. Okay. For the SN, do you guys get the same answer as go cancel? Or you get different answer? Okay, Tan Xinsheng get 5.171572 times 10 to the power -2 cm. Okay, this one is go cancel. This one is the Tan Xinsheng. What about the rest of you? You get go cancel one or Tan Xinsheng one? Okay, Wong Chung Yi get the different answer. 42 times 10 to the power -6 cm. Wong Chung Yi. Okay, let's see which one do you get. How many of you get this? Okay, let me create a poll for you to choose easier. Okay, you should go cancel. Wong Yi, Tan Xinsheng, or others. Okay, let's just see how many do you get. Okay. Interesting. Your answer is okay. Most of you can get the answer for the Tan Xinsheng. Okay, 19 work. What about the rest? Two of you get the one from Wong Chung Yi. Okay, there are some others put also. Means you get the other different answer. Okay, let's try this. Since we have a different kind of answer, let's see what do you get. Okay, in order for you to calculate it as n, since this one is in the reverse bias, you must consider the reverse bias one inside there. Okay, 2 us VBI plus VR over E NA ND NA ND. Okay, so this is the way that we do it. Okay, earlier our VBI is 0.2772. So this will be 2, 11.7 multiplied by one value. The value should be in this 8.85 times 10 to the power negative 14. Then 11.2772. This one over 1.6 times 10 to the power negative 19. And A and D given here. 5 times 10 to the power of 10 and A over and D 14 first, sorry. And A 2 times 10 to the power 14 and D is 5 times 10 to the power 10. Then continue do the addition. So this is the very huge equation. Okay. So let's calculate. Okay. So let me calculate. Two multiplied by 11.7 multiplied by 8.85. Oops. 0.85 times 10 to the power of negative 14. Okay, this one multiply 10.2772. Is somebody asking something? Let me see what have you asked. Yes, you are right. 10.2772. There's just a typo only. Typo or not typo because I'm writing one. Okay. And then this one divided by 1.6 times 10 to the power of negative 19. Okay, then you get this. And then you multiply by 2 multiplied by 10 to the power of 14. And then divided by 5 times 10 power of 10. Okay. Then you further divide it. You multiply by 10 to the power of 14 plus 5 times 10 power of 10. And then you square this answer 0.00265. Okay, 0.05175, which is the answer from the transition. Okay, everyone, do you get the same answer as me? So one of the weak point is this one. Maybe you didn't consider this. Okay, so Tan Xinsheng, can you give me the answer for the SP? Okay, 1.2893 times 10 to the power of negative 5 cm. For the rest of you, do you get the same answer as Tan Xinsheng? Okay. Okay, and then W will be equals to the Sn plus Sp. Okay, you can use this formula, adding up these two values to get the final answer. Okay, and then eventually you calculate your E. What is the formula that you are going to use for E? Okay, in order for you to calculate E, you need to use this. Okay, 2 VBI plus VR over W to get the final answer. So, transition, give me your answer of the W and the E max. Or maybe you change another guy. 陈旭偏, can you give me the answer of W and the E max? 陈旭偏. Okay, W will get 0.05158 cm. E max. Okay, 88.3. Ko Heng Dong, Ng Han Sen, do you get the same answer? E, you get 39.46. What about W? Do you get W? Okay. So this is 2 multiplied by 10.2, 10.2 something lah. Just now the value 10.2722 divided by 0.05158. Okay, let's try. 2 multiplied by 10.2722 divided by 0.05158. Okay, 39. Right. So this is the thing that we have done. Okay, any question at this point? By the way, today I think we will end the class earlier because we left a little part of this lecture only. Okay, if no question, then I proceed to the last part of today. This one I close down first. So, if we apply the reverse bias, so there will be the separation of the positive charge and the negative charge. If there is a positive charge and the negative charge applied on that, you will have the junction capacitance, okay, which is the capacity that we have, okay, that we learned in the very early. So this is a PN junction. Imagine this is a P, N, so this is all are N, all are positive. So positive, negative, here will be the capacitance charge over here, okay. Then if you're trying to apply the reverse bias inside there, you will be having higher capacitance. But how are we going to calculate the junction capacitance? So there might be some formula that you need to know. At first, we need to do some derivation. Junction capacitance we normally define as a C with an apostrophe here. Okay. Then this will be equals to the dq over dVr. Vr is the reverse bias. Q is the electric charge. Then the dq we can further write it as a E dN dsn over dr dVr. Okay, this is a standard formula. Okay, dq will be equals to the E and then this one is the donor concentration and the distance of the Sn. But how are we going to utilize this? E is a constant and D is a constant. We need to derive the dsn and the dVr over dVr. In the earlier, we know the Sn will be equals to 2 permittivity VBI plus VR over E NA ND NA plus ND square root. Okay, since we are going to derive this thing with respect to the VR, okay, right now we want to create a formula by linking the ND and the SN for us to calculate the capacitance. In order for us to need to calculate the capacitance, we must use all the info that we have learned earlier. The info that we need is a NA, ND, VBI, and VR. Okay, these four important things are the ones that help us to calculate the capacitance. But how are we going to derive the thing? So at first we assume this one as a first. A will be equals to the NA, ND, 1 over NA plus ND. Okay, Sm we can rewrite as 2 us VBI plus VR over E multiplied by the A. This is the Sn. Then we go to differentiation, sorry. dq dr dvr equals to the END dsn over dvr. With respect to VR, since the VR is already here, we can do the differentiation over here. dvr 2 us VBI plus VR over E A. Then square it, don't forget. Okay? Forgot to put a square root here. Square root very important. Okay, since this one is differentiate according to the with respect to the VR, we go back to the simple formula last time that we have done. Let's say we have something like this. If we do a dy/ds, then at first we carry forward here, this one to here, half 3 plus s, half minus 1, and then we need to multiply the derivation inside, which is equals to 1. If we have something like this, 3 plus s half dy/ds, it will become half 3 plus s, sorry, if we have put here 2 here, 0.5 multiplied by 2. Okay, hopefully you still can remember all the differentiation. So we do the same thing according to this formula also. So we put this here, E and D. Then we move this half divided by 2. And then 2 us VBI plus VR E A. Then we need to multiply the derivation inside here, I think. So this thing we can split into two parts. One is the constant, another one is the one with the VR, the variable that we need. And then we can further write it down here, derive until in this way. Okay, at this point, can you understand? Derivation here, at this point, can you understand? Okay, okay. Okay, low tone say okay. What about the rest of you? How many of you KO? If you KO, then that will KO. Okay, Long Yao can say okay. Okay, majority of you say okay. So I proceed from here. Then we continue to do the derivation. Okay. So since this one is a half, this one we can move. We can delete. We can delete. This one can delete. Can delete. And then we are trying to do this US, A, and D, E, 2, US, VBI plus VR, A, half. Since we have a negative here, we can inverse it. Okay, then we proceed from here. So this one half, this one here. So this one move, we still can have a half here. A, still can get a half here. Then we rewrite this. This is let's say E, US, A half, 2, VBI plus VR, and D. Okay. Then we try to put the NA back. NA will be equals to the NA plus ND US. Okay, this one should be here. Should be here. NA ND NA plus ND derived by divided by VBI plus VR half ND. Okay, since ND is here, also ND is here. Okay, so this thing we can remove, then we left a half here. US NA ND divided by NA plus ND 2 VBI plus VR half. Okay, and then we can try to further move it into bottom here. Okay, let me expand this. And then come to here. We can rewrite here to make it more nicer. 2 VBI plus VR and A plus ND square it. And this will be your capacitance. This formula is already written inside here, this part. Okay, you can see it will be exactly the same here. Okay, at this point, any question? Okay, can you understand? Okay, okay, oh. Very simple and easy. This one is just the derivation only, nothing much. But lucky for you, you don't have to memorize everything because the formula is already given here. All we need to do is how we going to utilize the formula only. Okay, so we can also do the same thing. We can use the mu s permittivity s divided by the width with the reverse bias. You can get the same answer. So normally you are given some kind of the question like this. Consider a silicon PN junction with the doping of the Na equals to 1 times 10 to the power 16 Nd 1 times 10 to the power 15 mu s 11.7 mu o. So this case is assuming the Ni 1 times 10 to the power 10. Calculate the junction capacitance C. Assume VR is equals to 5. According to the formula just now, this formula, oops, yeah, here. So we just need to replace all the value one by one inside to calculate the answer that we want. This one, 1.6 times 10 to the power 19, mu s 11.7 mu o, and a and b given 10 to the power 16, 10 to the power 15, divided by 2. VBI, VBI we have already calculated earlier. VBI plus VR 5, NA plus ND square root. Then you can get the capacitance. Okay, according to the slide, your capacitance will be equal to the 3.66 times 10 to the power negative 9. So if he asks you, this one is the cross-sectional area of the PN junction is, let's say if your area, if your semiconductor is something like this, okay, your area is given here, A. Your area is 10 times 10 to the power negative 4. Then if you want to calculate total junction, you just need to multiply the area with the capacitance to get your total capacitance. And then this one then is the capacitance in the farad. Okay. Earlier is the junction capacitance. Junction capacitance means that if per area, 1 meter area, what are the capacitance in one area? But if the total area, we need to multiply the area together. Okay, at this point, let's try to calculate another one. Okay, for example, silicon MD 1 times 10 to the power of 14 cm mass cube, Na 2 times 10 to the power of 10 cm mass cube. This one's in 300K. Then what else do we need? Let's see. Mu s equals to 11.7, standard one. Okay, don't forget, we also have our VR. Will be equals to, let's say, 3V. Okay, in this case, you need to calculate your VBI, W, and then Emax, and also the junction capacitance. Okay, let's try this. Okay. Anyone done it? Chua Yu Yang. What do you get for the VBI? Okay, VBI 0.2355. The rest of you, do you get some answer for VBI? Okay. On mailing, what do you get for the VBI? Okay. Then what about your W? 576 cm. Hu Hingdong, do you get the same answer as your W? What is the W? Mr. Hu? Okay. Emax. Let's see who else. Who else not here? Ko Bun Kyung. What about your Emax? Ko Bun Kyung, are you here, Ko Bun Kyung? You think wrong already. Okay. Let's see. Next one. Chia Chai Siu. You hear Chia Chai Siu? What's the answer for the Emax? One four 1.2882. Tan Xingsheng, do you get the same answer as the Chia Chai Siu? Okay, then here comes to the last part. What about the capacitance, junction capacitance? Lim Chun Wei. Are you here, Lim Chun Wei? What about the junction capacitance? What do you get for this? You calculate wrongly. Okay. Ng Wei Hong. What's your value for the junction capacitance? Okay. 2.2626 times 10 to the power negative 11 farad per cm square. Do you get the same answer? The rest of you? Yong Qi. Okay, thank you. So this is basically how we did it. Okay, very simple and easy only. All you need to do is to replace into the formula and calculate it. So let's go to the last part of today. So there's one thing we call as a junction capacitance, a one-sided junction capacitance. What is the one-sided junction? If some situation like this, Na is much more than the Nd, okay, then what happened to your total width? W, this one, VBI plus VR over this Na plus Nd over Na and D. And this one is a square root. So in this case, if your Na is much more than the Nd, so let's see, for example, if 100, 1000 is a Na, 1D is only 1, you can see this is much more bigger. Then you can assume that mu s VBI plus VR E. Assume that the upper one can be Na, more or less is Na. But Na, you still can multiply with Nd. Okay, so imagine if this is a 2, this one still valid, right? 1,000, 10,000 plus 2 is almost equals to the 10,000. But if you use 10,000 multiplied 2, then it's a different story. And then this thing and this thing, you can remove it. And then eventually you will get this US VBI plus VR E 1 over NT half. Okay. So this is the one-sided junction where your W is almost will be equals to the Sn already in this case. Okay. And then your capacitance, junction capacitance, you can also rewrite it into this VBI plus VR. Okay. This one we call as a one-sided junction. And then you can also manipulate it into the linear form. Okay. But how are you going to do it? So basically what you have to do is you do 1 over C 2 VBI plus VR E VS and D. This one is still 2. No. Yeah. So after this, we write everything again. Confused here already. Okay. So if you square this, we can do something like this. E U S N D 2 VBI plus VR. Okay. And then you do the 1 square root C square will be equals to the VBI plus VR E and D. Okay. So when you're plotting the graph, you can actually plot the graph 1 over C2 square corresponding to the VR. Okay. This thing you can further split it to the V VI E mu S and D plus 2 VR E US and D. Okay, looks like right now it become a linear equation. Okay, and then this one will be somewhere around here. Okay, and then this one is the gradient. 2 E mu S and D will be the gradient. Okay, so you can do something like this. Assume that the intercept and the slope are the VBI equals to 0.725. Then the slope is this. Slope is 1 over slope. Then this will be, let me see. Okay, slope should be somewhere around here. Yeah, this is the slope. The gradient is the slope. Okay, 6.15 times 10 to the power 15. So this one 1 over 6.15 times 10 to the power 15. Multiply by this and this and this value. Then we get this. But basically, this one nothing much, just for manipulating the equation only. Okay, nothing much important. Okay. So far, any question at this point? So as I mentioned earlier, we can end the lecture earlier for today. Okay, if there's no question, then I think we shall dismiss the class right now. Okay, thank you very much for the attention, and see you in this coming Thursday and Friday. You may leave the classroom now. Thank you, everyone. Have a nice day.